What's up guys, my name is Nobertus Budhya K, and today I'm going to tell you about two things. For the first one is the binomial probability distribution from the discrete probability distribution, and the second one is normal probability distribution from the continuous probability distribution. So let's go. So for the first one, binomial probability distribution. This distribution is part of discrete probability distribution, and distribution is used to find the probability that and that an outcome will occur x times in n performance of an experiment. So distribution can be applied if the event fulfills the following condition. The first one is there are n identical trials. The second one is in every experiment it has two and only two possible outcomes. So which mean it's mean that it has a success or failure case, or yes or no case. And the third one is the probabilities of the two outcomes remain constant. Okay, and then for the fourth, the trials are independent, so it means that the results obtained in the first trial will not affect the results obtained in the other experiments. And for the formula, the binomial formula is here. Okay, you can see here, this is the formula. And in binomial distribution, we can also find mean, variance, and standard deviation with this formula. Okay, and for the application of the binomial distribution in daily life, we can use this binomial distribution to calculate or count the probability of something that we did. For example, when we are preparing for an exam which is multiple choice, we can calculate the number that we expect we choose the right answer. Another example is when we calculate how many free throw that basketball player did for a season. We can use binomial distribution too. So that's all for binomial, and we can continue to the normal distribution. So for the normal distribution is one of the most used of all distribution. This distribution is part of continuous probability distribution, which means it has continuous random variables. If we represent in graphic, the curve of normal distribution looks like a bell, which is symmetric curve, and the parameter of this curve are mean that is located in the middle of the curve and also standard deviation. Okay, you can see this curve. This is a normal distribution curve with mean and standard deviation. So for the normal distributions have three characteristics. Okay, so the first one is the total area under the curve is 1, and the second one is the curve is symmetric about the mean, which means the mean divide this curve into two areas with the same area. And the third one, the two tails of the curve is extend indefinitely. And then there is standard normal deviation. So standard normal deviation is when the curve has mean equal to 0 and the standard deviation is equal to 1. The units marked on the horizontal axis of the standard normal curve and are denoted by z and called by z values. And we can choose any normal data to transfer it into the standard normal distribution. We convert it into the standard normal distribution. It can help us to make decisions about our data. We only need one table if we are using the standard normal distribution, and it's more easier rather than doing calculation for each value of mean and standard deviation individually. For the normal distribution, and to find the z-scores for the normal distribution, it has this formula. You can see right here. So this is formula to find the z-scores. And then for the applications of normal distribution in real life, okay, there are so many examples when we want to apply this normal distribution. For example, when we are working in factory that need assemble some parts, we can calculate the time taken for this factory to assemble the products. Another case is when we have to calculate the lifespan of a calculator. A calculator factory must know the lifespan of their calculator that they have made. So in order to know the lifespan of a calculator, they can use this normal distribution. Okay, I think that's all for me. Sorry if there is some mistake. Thank you.